Sir, am I audible?
Yes, ma'am, it is audible.
Okay. Thank you, sir. So, shall we start the session?
Yes, sure, ma'am.
Okay. Thank you, sir. So, very good morning to one and all present here. Today is the fifth day for our faculty development program. Also, it is the last session for our FDP. Today's resource person is Dr. PM Arun Kumar. He is currently working as an associate professor in the Department of Computer Science and Engineering at Karpagam College of Engineering, Coimbatore. He has completed his PhD in 2016 with a specialization of Information and Communication Engineering at the Anna University, Chennai. He is an accomplished professional from the Teaching Society with 16 years of teaching experience. He obtained his master's degree in Computer Science and Engineering in 2005 and he received his BE in Electronics and Communication Engineering in 2003. He carried out his research in the area of wireless video QoE and he published more than 10 research articles in reputed international journals. His research interests includes machine learning, wireless networks, medical informatics, algorithm design, and data analytics. He has received funds from various government agencies such as CSIR, DRDO, and ICMR to conduct workshops and seminars. He has acted as a reviewer for many international journals. Moreover, Dr. Arun Kumar has passion towards career counseling and neuropsychology. He has completed PG diploma in psychological counseling with a special attention to behavior therapies. He has a green belt certification and awarded global career counselor from University of California, Los Angeles. He has acted as a keynote speaker at various institutions and has delivered lectures in the broad area of engineering, cognitive psychology, and management. He has more than 50 certifications from Coursera, Allison, NPTEL, and Ascendus. He is an articulate communicator with demonstrated ability to teach and motivate the students' highest level. So, he is the right person for today's session. I welcome you, sir. Please, you can take the session now.
Thank you, ma'am. Yeah, very good morning to one and all. And I would, at the outset, I would like to thank the HOD and the coordinators for having provided me with this opportunity to interact with different faculty members from different institutions with respect to 5-day online faculty development program on deep learning for social network data analysis. I'm very much happy to interact with you all at this juncture. And before starting, I would like to know whether I'm audible really. I have presented my first screen and I would like to know whether I'm audible and the screen is visible.
Yes, sir. You are audible, sir. The screen also visible.
Thank you, madam. Thank you so much. All right. So the topic for today's discussion is Twitter sentiment analysis using deep learning. So I would like to go into the topic in a way that we can try to segregate or break this so-called topic of interest which I have given, Twitter sentiment analysis using deep learning, into 3 parts. Possibly that really will give you the idea and the so-called inference at the end of the session. The very first term is Twitter So we should definitely know it is one of the famous microblogging platform that has been used very extensively today. Number one, so we are picking that as the social network here for our consideration. Then sentiment analysis is one of the very famous and predominant technique or technology right now developing in all applications. So we are going to see what is sentiment analysis in a possibly in a generic way, and in what way that sentiment analysis can be used in analyzing the Twitter data. Then another thing is deep learning. This is another area, but of course it is interrelated. Now we would like to integrate all these things, how sentiment analysis can be performed in Twitter or using the Twitter data with the application of deep learning or with the usage of the deep learning concepts. So it's typically if you can see that there are two or three more important broader perspective that gets converged into a possibly one single research area. You can really say that this Twitter sentiment analysis using deep learning could well be a topic, a broader topic that can be explored for any people who are who are really interested in doing research in either you can point out as sentiment analysis as your area, or even the advanced machine learning as your area. It covers both. So it's one of the interesting area, and it has been taken as the point of discussion for today's session. Right. So with that, I would like to go into the topic. So there are a lot of terms that are used quite quite often now in terms of in the areas of data science, machine learning, or artificial intelligence in general. If you could see, there is a term data mining, which we have seen that as a very historically it is one of the important area in computer science. Data science followed by artificial intelligence, machine learning. Of course, without statistics, there is no machine learning. So that's also a core concept that is needed, or in a way that statistics, you refine statistics and statistical methods. There comes the machine learning algorithms. Then, of course, there is something called deep learning, which is taking up the momentum, or which has picked up much more pace than the other technologies. So everything is interrelated here. I think there is nothing called an odd man out out of these lists, but still we are trying to concentrate how deep learning, how have come up historically, starting from the basics of AI and the basics of machine learning that need to be seen here. So as I'm pointing out again, we would be seeing the concept of sentiment analysis and what it has, and how it is very much important in today's research and application wise, and how Twitter as a microblogging site has been used extensively in a way that there is always a scope that of applying sentiment analysis for Twitter data. And for that, there are a lot of methods. Twitter sentiment analysis can be done by many methods, of which using deep learning is of an important thing to be considered. So that's what I can conclude as a the title, and it's in the way that it relates with the topic of the FDP. What you do have deep learning for social network data analysis. So Twitter matches with the social network. Sentiment analysis definitely an area of interest here, and of course how it has been applied using deep learning is what we are going to see generically. All right. So social media, as everybody is aware of, we do use that very extensively. Social media definitely is a point where you could really see that everyone irrespective of the age group, everybody is using right now, whether you're from an academic or a non-academic or a very general person. So it has developed a lot in the last 10 years, I would say, which means no one is really going or being in the house without a mobile phone or without using a the social networks. So possibly it might be a YouTube or a Facebook or a Twitter, whatever might be the case, LinkedIn. These are all some prominent things you do have. So here the very important thing is in what way Twitter becomes very important in the context here. That's very important. As you know that most of the people or using Facebook, which means Facebook is ruling the world in terms of the number one the social media network that has been used by most of the people. Of course, it will be followed by all others, and I would like to point out on a few points on that, which will make you an interest here. So social media marketing is in fact is one of the research area, and it is one of the booming area. Why? Because why people are using social media is just not for giving up a news, or putting out their own perspectives, or chatting doesn't stops there. You have a business value in every social media network, which means it is a very big business now, in terms of advertisement, in terms of branding some products, or in terms of putting your thoughts or making your thoughts open to all others in a way that you can analyze the mood of the people, which will help you in improvising your business, whatever you take. So which means social media cannot be taken as like an entertainment factor anymore from here on. As you know that there are a lot of people doing business, and each and every company are getting benefited by having a presence, proper presence, with more connected networks among the peers or among the people, general public, which makes it as a one of the core thing that really gives you more business value. That is why it is booming like anything. So here, as it has been pointed out in the first point, for promotion of a particular brand, trying for a target audience growth, or increasing the sales, for each of the thing, your social media has been used effectively by using the marketing tools or marketing strategies, what I can call. So the social media marketing here will try to have, by sharing the content, what happens is that the brand, what brand you have, and that brand will have a better awareness among the public, and it will reach to the customer effectively. And moreover, this is one of the fastest growing trend. This itself, social media marketing itself, have become one of the research area. That is an interesting point to be taken. Then as you know that there are a lot of social networks available: Facebook, Instagram, TikTok, or Twitter, LinkedIn, Pinterest. It goes on. There are a lot more. Everybody knows, and almost all of us are, even a student community, or nowhere detached with those social networks. They are always glued into the social networks or social media sites because of the so-called attraction they have. So irrespective of the age, as it has been pointed out, Facebook everybody uses. Even a 50, 60-year-old right now, when you see, when you move in a bus, or when you move in a general transport, you can see everywhere people of some age group of above 50 or 60 even go into a Facebook, and they try to serve something related to their interests. So Facebook becomes the number one social network in terms of active users. Of course, this is a data taken up, say, 1 year before. So per month, statistics says that it is almost 2.4 billion, and followed by Instagram or even Twitter with more than 400 million. LinkedIn, as you know, it has been used by academic people like us for sharing our own thoughts, or even sharing our so-called credentials. LinkedIn has been used because for all the job opportunities and all job related communications, LinkedIn has been top notch right now. So these are all the things we know as a social networks, and of that we need to go into what you call it as Twitter. There are people who might have used quite often the Twitter as a site. There might be few people who might not be interested in it as well, because there is a small difference between the way you use or the end user who will benefit with respect to the interest factor they have in Facebook versus Twitter. So in general, Twitter, it was founded in 2006 way back, and Jack, as they call it shortly, Jack Dorsey is the CEO of the company, and of course it is from San Francisco, and it is one of the famous micro blogging website right now, number one in that case, right? If you had used it, I think what way your timeline will be like, and the terms associated with using the Twitter. When I say Facebook, you would we would always say that what is the like, how many likes you have, what post you have reshared or something like that. Here again, the terms, I can put a simple example. This is a screenshot of the Twitter account of a famous personality, sports personality, Sachin. So here you can see here in a way that it will be like this, where you do have, yeah, people can mute their mic if you haven't done that. I request people to mute their mic really.
Participants, please mute your mic.
All right. Yeah. All right. So this is what the screenshot of the Twitter page of Sachin. So you can see that it will be of a template like this. Everybody will have this particular template where if you follow, it will be like following. I'm myself following, so it is showing it as following. And this is the account of Sachin, the name, possibly how much number of people he is following. He's just following only 82 members, but see the amount of followers. As always, for celebrity, it will be always the number of following is much lesser than the number of followers. Followers will be very, very large. And of course, here you can see 35.8 million followers are there for Tendulkar right now. Possibly I have taken this screenshot yesterday. Probably today there might be a small change really, but this is the case that has been taken up in the as per the yesterday's database, right? So and this was the so-called recent tweet what he have done, possibly with respect to the test match that has concluded recently. And you do have all those things. I think I have given only the very first screenshot here, and you do have all those the sharing of the post, or replying to a particular tweet, and all these things will be followed. So here you need to know there is something called terms associated with Twitter, like tweets, replies, media, likes, and all this stuff, or the very general thing which you do, which means you will be writing a short burst of messages only. That can be done in Twitter when you compare to something like Facebook. You write all those elaborated contents can be shared and done. Here when you type something, it is up to a maximum of 140 characters previously, and of course now they have extended to 280 right now. Recently they have extended to 280 characters. So 140 was the standard number of characters that was there in Twitter, and to the maximum of 280 characters you can go. That's what you can do, which means it is that's why you call it as micro blogging. If you know why it is called as micro blogging website, because it is a blogging and instant messaging. That is the reason why it has been called as micro blogging sites. There are all other micro blogging sites. You can put it something like Reddit or Tumblr. You might have heard about that. These are all some examples of micro blogging websites, and in general you can call it as social media platforms or social media sites. All right, so this is what you need to know about Twitter. Basically it is a micro blogging site where you send and receive some posts that you call it as tweets. That's why you term it as Twitter here. So you can either follow few people, or few people will be following as well, and you can see something in the timeline is nothing but when you follow someone, you can see their tweets in your timeline, which means when you open up, that will be the one that will be coming up at the very first time to view it. So you can choose who to follow, who not to follow, and of course you can do all those things here. Retweet, as you know, that it's nothing but a sharing. When I do a sharing in Facebook, that is called as typically a retweet in Twitter. So when I have a content and I want to broadcast, or rather I have to send it to the other people who are connected to me, I will be using that retweet button. So these are all the things that has been used in Twitter. And why this Twitter is very important here for analysis, for any of the research purpose, is very important. As you know, when you compare Facebook and Twitter in general, of course the number of people who are using might be much higher in Facebook, and of course it has been launched in 2004 your Facebook, 2006 your Twitter. It is only for networking people, isn't it or not? Facebook, where you have more of an entertainment, most of the time it will be used for people to share some possibly their own stories, or some interesting news. Of course it will be there, everything will be there. Of course most of the time it has been used for networking with your friends or your colleagues, or even some unknown people whom their interest seems to be matching with yours. So that's networking people in Facebook. Whereas here Twitter is all about, of course, you connect with people, but here you are networking with ideas. Basically, you try to have a network of people connected in Twitter based on some sort of an ideas where each have their own matching in the ideas, really. So what happens is that there is almost 5,000 or even 6,000 tweets happen every second there are 6,000 tweets happening. So as you know that there are a lot of youngsters are using Twitter, and moreover it is an information broadcasting sort of a site. Twitter is for having a short burst of the so-called the new information or the news that gets viral right now will get projected, of course. So it's basically a more of an information broadcasting or information communicating sort of a site, but the value is much larger here, just because of the way your so-called the personalities and the so-called celebrities are more prone to use Twitter because of its nature, because of the instinct and the usage which is intended for Twitter. So that's a very important point. Now, as I have pointed out what is Twitter and why it is called as microblogging site, we will be going into the other aspect of where comes the deep learning really here. So as you know that artificial intelligence is a broad area, we are trying to create a machine that can learn and understand the feelings and the speaking of a human, which means it need to interact as like a human. That's a very bigger task. Of course, there are a lot of research going in, and there comes machine learning. You can call that as a subset of artificial intelligence, where exclusively we are trying to predict and the so-called happening by using the previous data or by using the historical data. We analyze and we try to predict something. There comes the deep learning, which is again called as subset of machine learning. So machine learning is a subset of AI, and deep learning can be called as a subset of ML. So that's what the picture really points out here. Right. So now I can straight away go into the difference between machine learning and deep learning. By assuming that you know exactly what is machine learning and the applications and working of machine learning. As you know that in machine learning, we try to give the input and we try to really give what is the output. We map and we try to extract the logic, isn't it or not? Machine learning, when you compare it with the conventional programming, in machine learning, we know what is input and output, and we try to make the machine to learn by using that, and we try to extract some sort of a logic. And by the way, what happens is that when a new data comes in, it automatically predicts. You can apply it in any example for any application. If it is weather, you have historically the weather forecast data and certain features and the final data about the weather of the last 1 month. By using that, use a machine learning algorithm. You try to train the machine or train and create a model in such a way that now I have a new data comes in, probably today's data, where I don't know really what might be the final prediction of the weather, whether it is sunny or rainy or gloomy, whatever the case. And now the machine, by using when you have an unseen data, it will take that. By using the learned model, what it can give is that it will predict and tell you what might be the so-called prediction for today. So that's the very base. You can apply it in any standard applications. It is in when you say health, you have some COVID data, and right now I have the 2-month data of COVID right now in a particular district. So I create a really a machine learning model using some standard algorithms, and I have trained it, tested it, and in such a way that you have a very efficient model right now on my hand. Now a new person comes in with some sort of a symptoms, which I call it as a features. By using the features, I feed that into the trained model, and that will give you exactly whether this new person who had come today have the possibility of acquiring that particular disease, say COVID or not. That can be done. So machine learning, there are a lot of types like classifications and regression models. Everything will be there, and I am not touching it just because that the topic doesn't warrant here. So I assume that you know at least some basics of machine learning and applications and certain algorithms that has been used in machine learning. Now the very basic point here is how machine learning differs from deep learning. As it has been pointed out in this particular picture, it's self-explanatory. Maybe for a people of your stature working in different colleges, this picture itself will give you a very clear understanding without explaining what it is. So you can see here in machine learning, I do have an input, And there is something called feature extraction, which is an important component or rather a step that has been used in ML, where out of all the features available, I need to extract the best possible features so that I get an accurate results. I cannot use all the features that will affect the efficiency of the system, as you know. So I need to extract specific features, and then I do the classification, and of course I will conclude the prediction. So here there is something called a car, and I am trying to take up feature extraction and classification will give you whether the one input taken is car or not a car. That is predicted. Whereas in deep learning, if you could see the same thing, but the thing is that the so-called steps of feature extraction and classification has been combined into one single step. So which means here automatic feature extraction is done instead of using the manual way of trying to extract the features. Here, as because of the property of deep learning, what happens is that automatically your feature selection or extraction is done. So this is a one single component which is done automatically, and again it will try to predict whether the input taken is a car or not. So the very basic difference here is automatically you are trying to have your the so-called feature selection or extraction and classification done, and that you need to associate with something called neural networks. The usage of neural networks to the highest potential by exploiting all the layers. What happens is that the automatic nature comes in, where the human interference become much more reduced than in machine learning, and it will give you much more accurate result than in few machine learning. So the very important point here is it doesn't mean that the deep learning is going to replace machine learning. No, machine learning, as you know, that you have a standard set of algorithms, you call it as a standard ML algorithms, wherein deep learning according to the merit or according to the need, if I am trying to have some sort of a image classification at the highest order, or if it is a text highest text classification with accurate results needed, large data, very large data, possibly an IoT sensor giving a quite a lot of data, their deep learning becomes much more effective than some standard machine learning. So which means it's an extension of machine learning algorithm, I would say, your deep learning algorithms, but the basic differences need to be known clearly. So this screen will give you the basic difference between the deep learning and machine learning. As you know, the data is very large. That's why we are going for a deep learning. Accuracy might be, when compared to machine learning, I think it will give a high accuracy. Again, you don't want to conclude that in general accuracy is high in deep learning and in general machine learning accuracy is less. No, not really. You need to think here, the point here is in what way you need to interpret this point is, compared to few advanced deep learning, your machine learning algorithm might be little bit lesser accurate, right? It doesn't mean that you simply ignore this machine learning algorithm cannot be done, right? Then training time, as because it's for large data, it might take a little bit of a longer run, and of course hardware, because of the data and the huge chunk of data, it requires GPU, where CPU is more than sufficient for ML algorithms, and tuning can be a little more better in deep learning. So this is what very general difference, basic 3 or 4 different points you can point out for deep learning versus machine learning. Then of course the deep learning, why we do is that the performance of the deep learning increases when the amount of data extends after a particular point, or the more large the data, the performance of deep learning becomes much better than other old learning algorithms. So if the application or the problem which you take is not for very large data, then you can go for normal standard ML algorithms. No need to go for a deep learning and complicate things, right? So it's for specific applications where deep learning will be much better. That is what you need to see here. Then about applications, as you know, image recognition, NLP, which we will be speaking because it is related here, video classifications, text to speech conversions, recommendation system, time series data applications, everywhere your deep learning will be used effectively. Moreover, all these are applications of ML as well as DL. You don't want to segregate there. Some basic algorithms have been used in recommender system as well. You know what is Netflix and movie sites, isn't it or not? Amazon or a Netflix, where you have some recommendations about what movie which you want to view hereafter. That recommendation or that chunk is based on what you have viewed and what you have purchased previously. What are all the movies you have watched, and with that, the Google or the so-called the platform recommender system platforms will assume that this is the genre you like, and the recommendations will be based on that. Same thing applies to any of the field, all are ML applications. I think I don't want to go into that in depth about the applications of ML. You just think about food ordering sites like Zomato or Swiggy. What happens is that you buy some products, food items, and you use that platform for ordering the food. What happens is that one fine day it will try to recommend a few restaurants, it will try to recommend a few food items. Those recommendations will be the one which you like, and that liking has been analyzed and it has been finalized by that particular platform by using your search history, your ordering history, your previous data. All these things will be taken up, and for business value, what they do is that they will try to recommend something for you. So those are all some very interesting applications, and it doesn't stop there. In every field, probably you take Gmail, spam detection. There is something called a spam which will be accumulated in our Gmail, and that spam, whether the mail is a spam or not, itself a working of a machine learning algorithm. It actually makes sure that certain mails to be matched and placed in a spam folder, whereas the others in the normal primary mail. So these things happens by using ML applications. I think these are all some standard applications you can think of. Here, I think the deep learning versus machine learning, again, the same thing. I think if you could see here, in machine learning, what we do is that we try to extract the features, what the roundness of the face or the distance between the eyes, nose with the eyes. So these are all the features you do have, and then you apply a classification algorithm and try to identify who the person is. Instead, in neural network, as I have pointed out in that car example, there is no separate feature selection or a feature extraction and classifying algorithm. Both are combined into one single thing. You basically have that advanced neural network working here in deep learning algorithms, right? So the bigger data sets, better hardware, very bigger hardware, and smarter algorithms are used in deep learning. I think it amount to something like more than 10 million labeled images. Such data sets can be effectively analyzed using deep learning, and hardware large, and of course some standard algorithms like recurrent neural network, convolutional neural networks are examples of deep learning algorithms. So there are a lot of applications in deep learning, like self-driving cars, handwriting generation, pixel restoring, deep dreaming as well. How to identify the delay in children. There are a lot of problems that has been encountered by children in early stage of their developmental errors. They do have delays in their cognitive capabilities. Those things will be detected effectively, predicted effectively. Demographic predictions, films, and news generation, automatic translation of languages from any of the language, automatic translation. Even if you have something like a board, signboard is there, and there is a you go to a place and there is a signboard in some other language which you don't understand. By using deep learning algorithm, within fraction of a second, what you can do is that you just scan that, it will exactly translate exactly what it has in the that's so-called signboard. So that is also even possible in real time by using all those deep learning algorithms, right? So now lot of deep learning algorithms available, and if you're really interested, you go and try to see the basics. Might be few people might have touched during this online FDP course with respect to the certain topics. Convolutional neural networks or recurrent neural network, LSTM, is also another famous one. DBM or DBN, everything has been used. And moreover, there is another thing which has been used right now in the recent days. You call it as capsule neural network, which I haven't pointed out here. If you are really interested, there is a new neural network type called capsule neural network, CapsNet, which is used. And in fact, what it concludes is that even the pitfalls in convolutional neural networks have been avoided, and it has been rectified in capsule neural network. Very new research area, and if you're really interested, you can go into those capsule neural network as well. So these are all some standard deep learning algorithms available. So as I am telling, internet, cloud computing, medicine, biology, everywhere, security, cyber security, autonomous machines, everywhere your deep learning can be used effectively. All right, now I would like to go, before going into what is sentiment analysis, I think you should know what is NLP, because your sentiment analysis is a part of the major area called natural language processing. So natural language is nothing but the one that we speak, normal text, what you do have, and we can apply the concepts of machine learning here effectively. So general steps of NLP is like this: morphological processing, syntax analysis, semantic, pragmatic. These are all the analysis generally you do in any of the natural language processing steps. Here what we try to take is the text, and we are trying to analyze the text. So we need to see how far the syntax is better, semantic is better. Semantic determines the meaning, syntax determine in what way you can write a particular sentence or a paragraph. All these things are important. Maybe I can touch upon that because it's closely related with sentiment analysis. So if you can see, morphological processing is breaking the sentence into words. Syntax, as you know, that whether the syntax is well formed or not. There might be a few sentences, the school goes to boy, something like that, which doesn't have any meaning. So that syntax need to be taken up. Example, I'm putting out the school goes to boy. The boy goes to school is correct, whereas the school goes to boy is not correct. So that will be captured by the syntax properties. Similarly, semantic is about meaning, as you know. The dictionary meaning need to be taken up, and if there is any variation in that, that will be captured here. Pragmatic analysis is another thing where two or different context and so-called errors or meaningless things will be rejected in pragmatic analysis as well. So ambiguities, as we speak about, when I say lexical, the same word can be used as a noun or adjective. So there comes the ambiguity in lexical formats. Syntax wise ambiguity, as you know, the man saw the girl with the telescope. It's possibly a syntax ambiguity because you can see that the man saw the girl with the telescope, which means whether you need to assume that it's a girl who, that particular girl is having a telescope, or the man saw the girl with the help of the telescope. You have two different meanings for the same sentence, isn't it or not? So that becomes your syntactic ambiguity. Semantic ambiguity, the meaning, the car hit the pole while it was moving, the meaning becomes absurd here. Similarly, there are anaphoric, phoric ambiguity as well, where there is a term called it has been used and you don't know whether that it specifies one particular component of the sentence or the other. So these are all some ambiguity you need to address whenever we try to analyze the text. Very important. We are trying to analyze a text for some information or some sort of outcome, which means it is much more difficult than the normal analysis which you do for a generic data. A normal numeric or a non-numeric data is much more easier compared to the structural data, what you call it as unstructured data here. The text, you call it as unstructured data, and analysis of unstructured data is much more complex compared to the analysis of structured data. Structured data, you put some values, some numerics, and some sort of a conclusions there, whereas unstructured data is some non-standard things like text, images, or even information about the video. Everything comes under unstructured sort of an input, right? So basically what we do in NLP is you segment it. There is something called tokenization, where we separate your sentence into words and we predict the parts of speech. Very important. Parts of speech is we are trying to see which one is noun, which one is verb or adverb, something like that. Lemmatization is another important term or the process or the step here, where we try to see it reaches to what lemma there, and identifying the stop words, where you can see that yeah and these are all the terms which gets repeated, doesn't have any meaning. So I can remove all those a, and the in any of the text, whether the text is 1,000 words or even 50 or a 60-page content, I can remove a and the, because that doesn't have any impact in the final analysis. So parsing and named entity recognition is another step where you should definitely know. Maybe I can point out on something like how to tokenize thing. I have a sentence, I separate into words. What are all the verb and noun, which is nothing but parts of speech. And lemmatization is trying to have the the root word. We are trying to find the root word here. Play, playing have the same meaning, so I can put it in one bracket. Similarly, stop words like a and the can be removed. NER maps the word with the real world places, because maybe an example like when I say Washington as a term, it might be an area in US, or it might be even a name, isn't it or not? So a good NER system need to identify whether in the context in that particular paragraph, whether they are referring to the place Washington or the so-called person Washington, that need to be identified, and that is difficult, but still a better NER system will try to identify it properly. So these are all the things you need to know under NLP. Maybe the stemming and lemmatization are very important terms. As you know, stemming, what I have told is that drive, driving, drives, all or same meaning. So I can take it as one single type: nation, national, nationality into one. Similarly, lemma is little bit different, a variation of your stemming where better and good have same meaning. So I need to put them in same bracket. That you call it as lemma. So these are all some points to be noted in NLP. And you can use deep learning in NLP for processing the text and getting some outcome. We are trying to process the text and we are trying to get some insights, some actionable insights from that particular text can be done, right? So DL has been used effectively in many medical fields, electronic health records, identifying and readmitting the patients. There are a lot of health records available, text data. You can analyze the text and you can predict and get some information or an outcome from the text as well. So these are all some basic, maybe I can skip it off. These are all some sort of research going in terms of sentiment analysis and deep learning. Right, I go into what is sentiment analysis here, very importantly. Right, so what is sentiment analysis? We try to classify the emotions. Everybody have a sentiment, and everybody will really show the sentiment in many forums. Like whenever you purchase something or when you have a forum, you will try to write your feedback. In fact, you call it as a feedback. This product is good or this product is not at all good. So these sort of feedback will be collected by the company or by some sort of an institution, wherein they will analyze those feedback and they will try to conclude whether the product has reached in a better way or the product has failed miserably. They can conclude that. That is what a sentiment analysis is all about. So it is interpretation of whether it is a positive comment or a negative or a neutral. That's simple your sentiment analysis is. So you can even call sentiment analysis as opinion mining. That is another term. Sentiment analysis can be called as opinion mining. So the tools related to sentiment analysis will allow the business, because I am a very big company who is having a particular product launch, maybe a mobile phone I have launched. Now today there are many people have bought that mobile and they discuss the plus and minus of that particular mobile in some forums, possibly in their own website or in one of their microblogging sites, whatever the thing. Like Twitter, they will be putting it like this mobile phone I have bought it today. It is one of the best in terms of camera quality or in terms of speed or something like that, which means it's a positive comment. You think about that as something like, I have bought this particular watch today. It is not at all worth. It is not at all having the same features as pointed out in the in their website, something like that, which means a negative comment. You think about a comment like this particular mobile is very good in terms of so-called camera, but it is but the weight of the mobile is much higher. When I have a sentence like this, what it means is that first sentence seems to be a positive one. Along with that, you do have a negative comment. So in what way a computer can classify these things into positive, negative, so that the whole collections can be analyzed, and the output will help the company to improvise, help the company to understand which product is performing better in the market, which product is not performing better in the market can be analyzed. And that is where your sentiment analysis and the research in sentiment analysis have been directed towards, right? So now you can see here, this is what it means, a document or a text you take, and I would like to see whether the what is the sentiment of that text, whether it is a happy content or the text actually denotes a positive content or a negative content or a neutral one, or the person is very angry about the product or the service, whatever, and that the text content really shows that maybe they need some improvisation. So those conclusions can be done in by the end of using sentiment analysis. So what is the classification of sentiment analysis? Very important. If you can see, sentiment analysis can be done by two major approach, like machine learning as well as lexicon based approach. You remember, sentiment analysis is nothing but we are trying to extract the sentiment of a unstructured data, something like a text document. So here you can either go for a rule based approach, what you call it as lexicon based approach, or another name is rule based approach, or a machine learning approach. So when I say a rule based approach, what will happen is that there will be a dictionary, and the dictionary will have the terms for positive as well as negative, and the word what you have in the text will be mapped to the dictionary, and accordingly they will be giving the score. It's very simple. It's a dictionary based approach, what you call it as lexicon based approach, whereas machine learning approach is little different, where we apply standard machine learning algorithms, and by the way, by using such algorithms we are trying to predict the sentiment of the text document or of the unstructured data, whatever you do have. So that's a very basic difference. And remember, we are trying to do a Twitter sentiment analysis using deep learning, which means we are trying to take the data, the so-called data from a microblogging site like Twitter, and we apply the advanced machine learning algorithm, which is not shown here, which is just the opposite of lexicon based approach. So advanced deep learning algorithms for sentiment analysis by the way of exploring the Twitter data can be done effectively. So this is a very standard classification diagram or a tree which shows what way your sentiment analysis can be done, right? So this is what happens in general. If I have a sentence like this, it is fun and easy to do sentiment analysis. Very example, simple sentence now. One sentence. Now the fun and easy are the keywords which actually shows that it is a sentence that denotes something positive, isn't it or not? It is fun and easy to do sentiment analysis, where fun and easy, maybe if you map with some score +1 and +1, this total sentence will have a score of +2. Maybe you can term it as a positive content. Whereas I don't like reading all of the negative tweets. What it means is, like, though you have a word like, it is combined with the don't. So it's a negative impact. So don't like becomes a -1, one negative comment, and another negative is a word that itself is negative. So that's another -1. Maybe -2 might be a thing that you can associate as a score for this particular sentence. Probably it is not that easy. You remember, you do have a lot of things to be taken up before applying sentiment analysis, because it won't be that easy like these sentences. You may have a combined thing where you have a positive as well as a negative. So there you need to apply the machine, or the algorithm should work properly. Similarly, a lot of sarcasms will be there, isn't it? It's as because it is a text and it's an unstructured way, we will do something sarcastically. What is this class? Semma class by the idoru class is Semma class inniki abdina. What it means is that he doesn't like that class really. He put it sarcastically. You cannot point that as a positive comment, isn't it or not? So those difficulties and the real time difficulties comes in an implementation wise in sentiment analysis that need to be taken care by the algorithms that you are deploying for exploring the sentiment analysis, right? So there are a lot of types of sentiment analysis, like rule based and automatic, which I'm speaking. Rule based, you call it as lexicon based, and automatic, you can call it as machine learning based or deep learning based for that matter, really. So sentiment analysis work as like the normal structured data. Here you do have an unstructured data, text. You extract the feature. By applying a feature, you apply the machine learning, you train the model, and once the training is done, if it is good enough now, you create that model. Now a new text comes in, really a new text comes in. Possibly what happens is that it will classify whether it is a positive comment or a negative or a neutral thing. So that's how your sentiment analysis really work with respect to a machine learning model. You remember, this picture is for how a machine learning algorithm model used in sentiment analysis work. So why sentiment analysis? I think I have told you already. Social media monitoring, brand, customer service and market research, everything. Your sentiment analysis will give you a better understanding and outcome, right? So now I am coming to the last part of this session, which is where your sentiment analysis is used in deep learning. So deep learning, as you know now, if you could really see what is the one that we have learned right now. Deep learning is powerful neural network algorithm, and which means it is used in many advanced application like translating language, recognizing speech and all that stuff. So which means it will identify and learn the pattern from both unstructured and unlabeled data without human intervention. You remember, that is why sentiment analysis, which deals only with the text and all unstructured formats, is very much used along with the deep learning. Deep learning inherently have the capability of exploring unstructured data better way. That's one of the advantage you have in deep learning compared to standard machine learning algorithm. That is why sentiment analysis can be used along with the deep learning algorithm to get much better accuracy. That's one takeaway point you need to know here. Similarly, sentiment analysis, as you know, that it is it refers to something like text analysis, computational linguistics and biometrics all combined here. So here the NLP and the so-called sentiment analysis, which is a part of NLP, which is a very good candidate where your deep learning algorithms will work effectively, right? So as you know that's what's taken up here. You can see here again the same concept in a better way. Now the text, as usual, you have pre-processing will be done as usual, but in machine learning what you do is that you extract the feature separately and model it using some machine learning algorithm, and the output will be a sentiment, whether it is positive or negative. Instead, in deep learning, I think you can map the generalized diagram what I have shown. In deep learning, same thing, text will be taken, pre-processing will be done as usual. Whereas here in deep learning, what we do is that we do an embedding or a neural network concept comes in, where the feature extraction and modeling combined into one single unit in such a way that your sentiment has been classified as positive or negative. This is how your so-called sentiment analysis work with respect to machine learning and with respect to deep learning. So now the last component here is Twitter sentiment analysis using machine learning or a deep learning for that matter. So Twitter, as you know, that a lot of people are using, so you have a lot of information in Twitter. So it will be used for marketing. It will be used by the politicians to gather what actually the people are having as a what really think about the next election. That's how your US elections have been conducted previously. When Donald Trump got victory, there what happened was he actually used Twitter to the maximum benefit, where he gauged everything. What is the mood of the people, what they are thinking, which are all the activities people are really not liking, and accordingly he modified his intentions and the so-called his rules, or rather applying some implementations. Thereby he got success as well. So here in politics, gauging the people's mood can also be done by analyzing the text people really gather, or rather the what text they really make in social media sites like Twitter. That will be taken up and it will be analyzed. So political parties understand the public response to the policy changes by analyzing those text data. So now what are all the steps that you can do for Twitter sentiment analysis using deep learning? As usual, text pre-process, which means you clean the data, tokenize and stemming. As you know, tokenization is nothing but break the sentence into words, and once the words is there, you try to stem is nothing but bring the roots. If they say, for example, happy, happier, happiest, all the three denotes happy, so you make it as a generalized call happy. So that stemming process will do that. Then you go for word embedding techniques, where you have bag of words type, term frequency, inverse document frequency, another TF-IDF methodology, one of the standard feature selection method that has been adopted in sentiment analysis, or word to vec. Word to vec is also very much famous. Now it has been used quite extensively. Then you model that, and using the performance metrics, you try to see whether that model is better or not and extract the results. This is what the steps you do. Maybe I can see there are a lot of Twitter data available for you to analyze. One such data, standard data already available in the net is sentiment 140 data set. It is named as sentiment 140. It is available, where it contains some, you can see how much number of tweets it do have. Almost 16 lakh tweets can be taken up, and the columns are target, IDs, date, flag, user, and text. So these are all the so-called features you do have. Target is nothing but the class label, as we point out for any of the machine learning algorithms. So that target will be either a positive or negative. This standard data set with this much number of input, you process it using a deep learning. In what way? Possibly you take that particular data. I think this is another example of another data set available, standard data set. I think you can see here something like this. What tweet you have? This is the data you have, input sentences you have, you are analyzing the number, possibly a number associated with that, and the label. You can see 0 or 1. 0 means I think it's a positive one. Negative tweets maybe for 1. So you take up all those things, make the model to get trained. And once that is trained, now a new sentence comes in, new input, which is nothing but a new sentence comes in. That will be classified as whether it is a positive or negative by the machine itself automatically. That is the advantage you have in deep learning. So you can take any data set. There are a lot of Twitter data sets available in the net, or in any of the resources you can search, and you can get if you're really interested. Next one is text processing. As you know, as I am pointing out, tokenization and stemming will be done. Cleaning here requires a lot more. In Twitter, what happens is that there might be a lowercase or uppercase. You need to make it in one single case. Mentions, there is something called mentions. As you know, when you if you had used Twitter, you know what is meant by a mention. Possibly you are trying to mention something to a specific person, where you will be using an @ symbol. You remember there is an @ symbol which you put to mention it to a specific person. So you can remove that @ symbol as and when it comes, because it doesn't have any impact in the analysis. Similarly, remove the special character, stop words, which means a, and the hyperlink. There are a lot of hyperlinks will be there in Twitter data. You remove that. Numbers, white spaces, you can remove. Everything comes under cleaning of data. Then what happens? Tokenization, as you know, break it. Stemming, as you know that, go to the root word. Satisfied, satisfaction, satisfying. All goes to satisfy. So you apply that stemming process. Then word embedding is nothing but conversion of your actual data, which is in text format, to a numerical value. It's you call it as vectors. Very important thing. Word embedding is an important process in sentiment analysis, where you convert your text and map it to a vectors. So for that to be done, there are a lot of new terms like document. Each text data, you call it as a document. Entire document, you call it as a corpus. These are all some standard terms. Now you can see different text processing can be done by techniques like bag of words. TF-IDF is another famous thing, and word to vec as well. There are three techniques that you use in text processing. Bag of words, possibly you transform using a dictionary. Based on dictionary, and you try to segregate those words in the sentence. That is bag of words. TF-IDF is different, where you calculate term frequency and inverse document frequency. That TF means term frequency, IDF means inverse document frequency, where term frequency, it is nothing but the relationship between word and document taken up, whereas inverse document frequency will give the relationship between the word and the corpus. You have a difference here. Corpus, word na document na, you should know really. That has been given here. What is document, what is corpus? These need to be taken up here. Similarly, you have your formula for term frequency, like number of times a word is present in the review by total number of words. That gives term frequency, whereas IDF, total number of documents in the corpus divided by number of document which contains that word. We will be always using a log in inverse sort of a document frequency. So here term frequency will give you really when it is high, which means that the word is frequent in that review. High inverse document frequency means when it is high, you can say that the word is rare in the corpus. So you have a different meaning between those two. And how to calculate TF-IDF? It is not a separate thing. I have told you what is TF and what is IDF. In fact, to calculate TF-IDF, what we do is that this is what we do. TF-IDF of the word in the review can be given as TF, term frequency multiplied by IDF. So term frequency relates with word and review, whereas IDF relates with word and the corpus. So this is how you really use your the feature selection in sentiment analysis. A lot of methods available, of which this is one of the method. Right. Similarly, word to vec is another one. Instead of going for converting a sentences into vector, here what we do, each word will be converted into a vector. That's a specialty of word to vec. So that has been used uniquely in many of the advanced deep learning concepts where sentiment analysis has been used effectively. You need to go in, dig deeper into these concepts while you are implementing deep learning for sentiment analysis projects. As I have told, you have the processed tweet, and because of word embedding, what I have told, word embedding is nothing but these three methods. Any of these three methods. Word embedding, what you try to, yes, this is what your word embedding, of which you have three methods, bag of words or TF-IDF or word to vec. Anything can be used, and using that, what I am trying to do is that convert my processed tweet into vectorized tweet. Then what I will do is that output will be given for model fitting, where I will develop a model using any of the deep learning algorithms. Then I will try to see what performance it really makes, which means in the model fitting, what it will do is that I will test, I will train the data using training data, and using test data, I will try to see what accuracy it has. Now, based on the performance metrics, something like F1 score or a precision or accuracy, as you know, all performance indicators, what we use generally using a confusion matrix, we try to see in what way that text document, whether it is positive or negative. So that will be analyzed, and the final output will be taken up. This is what the total processing steps that can be applied in Twitter data sentiment analysis using deep learning. So as you know, what are all the performance measures used? Confusion matrix, as you know, for a text, the same thing. True positive, what might be true positive here with respect to sentiment analysis? So it is you predict it is positive, the content is or the text is positive, and actually it is also positive. That's true positive. Whereas true negative is nothing but actually the text is negative, and if the prediction is also negative, that's true negative. Whereas the very important thing is false negative, where what happens, actually it is positive but the prediction gives negative, it's false negative. Actual negative, I mean, and predicted positive, you call it as false positive, right? So this is a confusion matrix. You can apply it for any of the machine learning. You use confusion matrix, and using this TP, FP, FN, and TN, you will be using all the formulas like for accuracy, precision, isn't it or not? Recall and F1. These are all the performance indicators used by machine learning and deep learning algorithm to determine how far the algorithm is working. What is the accuracy? How far the algorithm is performing compared to other algorithms? These are all the measures you need to take it up, right? So I think we are running out of time, which means you need to see how far your underfitting and overfitting is all about for any of the algorithms. Yeah, madam, can I finish off within 2 or 3 minutes now?
Okay, sir. Okay.
Another 3 minutes, I will finish.
Okay.
Right. So underfitting and overfitting is another important thing to be noted. Probably I will let you know what is underfitting and overfitting with an example, which you can tell for students. They will understand very clearly using this example. And it is one of the standard thing to be noted. Your algorithm should not go for any underfitting or an overfitting, any of the algorithms for that matter, whether it's an ML algorithm or a DL algorithm, right? Maybe I can give this example, which you can possibly while you're taking a class, it will make an interest to the students. You just remember how to understand what is underfitting and overfitting. Probably an analogy will do that. What analogy is that? You just have a scenario where there are 3 students in the class. One student A, she won't study anything. You assume that she is one of the poor students. She doesn't listen. She doesn't understand anything. She doesn't even score any marks. And there is another student called B, who is very much a student who will be very obedient. And in fact, whatever the teacher says, he will obey. And in fact, what way he learn is that he memorize everything. You remember that there is a person B, second person will memorize everything, which means he will score considerably well. Third person, you assume that she is a person who will be analyzing all the concepts and she will learn according to the merit. She have all the learning capabilities, understanding and problem solving capabilities. Accordingly, she will attend the exam. So there are 3 people. One person doesn't study, doesn't care. Second student, he will memorize everything and will write. Third person, ideally the best person, whom will take up and read and write according to the problem solving capabilities. She will understand the concept and apply it. That's the way she will do. So these are all the 3 people, and assume that there is a professor for taking class for these 3 people, and they are trying to keep something like a class test. They are trying to he is making a class test now about for his subject. What happens, what might be the result is that, maybe I can conclude it as because there is no time available here. For a class test, you assume that the professor will be asking possibly the questions what he discussed in the class, isn't it or not? You just think about an internal assessment where the questions whatever discussed have been asked for the students. Now what might be the result is that the A student who never studies will get a very poor result. What happened to the B student who memorize, as because the question is from the same questions that has been asked and discussed in the class, this second student will also score very good marks, isn't it or not? Probably above 80. Third student, as you know, she will analyze and she will understand and write. She will also get good marks. So this is the case for what? The internal assessment. Assume that there is an internal test happen, which means the questions are nothing but the questions that has been discussed in the classroom. Now you have this scenario. Now think about, there is a scenario where they are writing the end semester final exam, where the question is not from this professor, it is coming somewhere else. So now the question is not the same discussed in the class, probably similar question, but with a different perspective they will be asking. Now, what might be the answer or the performance of these 3 students? The first student, as usual, she doesn't know anything. She will be very much poor, score very, very less, possibly a fail mark. What happened to the second one? Very important. B student who is supposed to do all the memorizing, he might not get the good marks here, because the question is not the exact question. It is a question that has been taken up by somebody else, which needs little bit of understanding. As because he memorized everything, he cannot score good marks. What happened to the third person? She, as usual, will attempt the exam and get good marks. Now, the difference finally is that, as because the second student is memorizing everything, he could not write well for a new one, which he doesn't have seen already. So that is what you call it as an overfitting. You just assume that an overfitting is one where the data fits to the training data very well in such a way that it doesn't classify the new data properly. You call it as overfitting. Here in this example, this person who memorize everything cannot get better result when a new unseen data comes in. That scenario you can relate it with what you call it as overfitting. What is underfitting? Underfitting is a one where it doesn't classify well and it doesn't works well. That's the very first case you have. So that overfitting is a very important thing where it does not work and classify better when a new data comes in. So such overfitting need to be avoided in deep learning algorithms. This is what I want to conclude. And the very final slide is you do have something like this. When you say sentiment analysis, deep learning, what is the applications and what review you do have, what sort of a sentiment analysis task you take, and you need to learn deep learning models, convolutional, recursive or recurrent neural network, and you get a result. Accordingly, your performance will be evaluated and results will be taken up. This is what I want to share with you today. And with that, I definitely would like to thank everyone who have listened to this session carefully and patiently. Thank you, one and all.
Thank you, sir. Really, the session is wonderful. So, participants, you have any query?
Sir, can I have one doubt, sir?
Sure, sir, sure.
Sir, can you explain very well in deep neural network and all, sir? Can I give a key points about a conventional neural network as well as deep neural networks? Which one is best for providing security in image processing?
No. Here, the thing is that deep learning in general is very much secured in terms of applying when compared to normal machine learning algorithms. Say, when you say about security, I can tell you all security and image processing. I can give a very simple example. You just think about there is something like radiology department in medical field where there are a lot of CT scans and MRI scans comes in, right? If you are applying an image processing sort of a project there where you are trying to assess the security of those images, your so-called deep learning algorithms will perform much better than conventional machine learning models. Definitely, yes. Out of the deep learning algorithms, which one seems to be better? That is up to the data scientist or the programmer or the so-called deep learning scientist to explore the actual input data, what he or she has. And according to the merit, he need to conclude that which particular method is more efficient. It depends on what data we have, and moreover, the way the data has been used in terms of security. So what I can say is that under deep learning, which model is better is up to the so-called the researchers to conclude while they are applying their model to different algorithms. When you say which model, whether the basic machine learning model or the advanced deep learning models, which one seems to be better for cyber security aspects, now deep learning will be much better. You know why? Because all the deep learning models has the basic structure of neural network where they stack in the layers. All right, there is a hierarchical stacking of layers happening in deep learning, which means your security can be made intact. And moreover, an example like this, a radiologist trying to finalize what is the image representation in a MRI or a CT scan, there are a lot of so-called intruders who may go in and try to change the so-called input by using advanced methodologies, hackers. So for that, advanced deep learning methods will be much better than the conventional method. I hope I have answered your question. Yeah. Moreover, you can even go for that capsule neural network, which is very much new. Wherein the difference here is compared to convolutional neural network, capsule neural network will take on the spatial differences. You get my point here. Maybe I can put a very simple example. You assume that there is a face, recognizing and analyzing a face. For a face, there will be two eyes, one nose, and one mouth. All right. So conventional neural network, what it will do is that it will try to gather those details in such a way that whether there are two eyes available, whether there is a nose available, a structure of a nose available, and whether there is a mouth available. If these components matches, most of the time it will say the face is perfect and it is a face of a particular person. But what happens is that you assume that the same face where your so-called eyes will be at the same position, whereas another eye will be below your mouth, something like that. If that is the case, that's a spatial relationship you need to explore. For that, instead of convolutional neural network, you can go for capsule neural network that will take care of those spatial relationship better way than the previous one. That can also be taken up. Thank you. I hope I have answered.
Any other question? Any other queries, participants?
Hello, sir.
Yeah.
Sir, there's stemming and lamentizations are same, sir.
No, sir. If you can say that, I can give a very simple example. Stemming, as you know that, it's trying to find the root word. As you know that, if I say that happy, happier, happiest, happy. Lemma is a little bit different, where you need to find out the root in terms of dictionary. Say, for example, good and superior. Good and superior need to be put in one particular bracket, which cannot be done by stemming, whereas lemma will do that. You get my point here?
Yes, sir. Yes, sir.
There
You
is a
told,
difference.
I think, that better and good.
Better and good can be
Okay.
put in one
Yes,
bracket by
told,
using
yes.
lemmas,
Okay, sir.
whereas it is not happens in stemming process.
Stemming. Okay. Thank you, sir. Thank you.
Thank you so
Excellent
much.
session, sir. Okay.
Thank you. Yeah, thank you so much for your patient listening, and thank you for the coordinators also. And being in the same department, I should also thank all the participants who have really attended these sessions for the last 5 days, I suppose. And thank you for your participation.
Thank you, sir. So, as a time to thank, I would like to thank our management. Also, we thank our principal and HOD madam. I would like to thank all the resource person for last 5 days. All the participants are given a very good cooperation to conduct such a wonderful FDP. So, thank you one and all. Thank you so much. So the
and participants will be receiving your certificate within a week.
The feedback link is posted in the chat box. Please, all the participants will fill the feedback. The certificate will be issued within 3 days. Thank you. Thank you, one and all. Prakash, sir.
Yes, madam.
Sir, recording is going on, sir.
Oh, correct, madam.